Good afternoon, everyone, and welcome to today's panel discussion. My name is Amr Radwan, and I am the CTO and co-founder of Tenix Technologies. It's my pleasure to be here with a couple of really industry experts that in the front line or in the Permian. Together, we're gonna explore one of the most critical topics in the industry. We're going to be talking about the operational, technical, and economic challenges in the oil and gas production in the Permian. So specifically, we will aim to identify key production bottlenecks. We're going to explore innovative strategies and technologies that can help optimize production and improve efficiency. And we also going to discuss the economics and some ESG related hurdles that impact operations and how the industry can generally adapt to them. So here's how our session would flow today. We will start with a brief introduction of our panelists, followed by about 50 to 55-minute discussion covering some of the most pressing issues and breakthroughs. Then we will open the floor for a 15-minute Q&A session where you guys can engage directly with our experts and ask them any questions you might have. So to help us navigate this discussion, we have two estimated industry experts joining us today, Yogesh Branden from Chevron and Pronk from Dwiggins Consulting. So thank you guys for joining us today, Yogesh and Branden. Could I ask each one of you to please briefly introduce yourselves and just share a quick 1-minute overview of your backgrounds with our audience today?
Ladies first.
Thanks, Branden. Hey everyone, my name is Yogesh Pradhan. I also go by Yoshi Pradhan if you can't pronounce my legal name. I work for Chevron and I've been with the company for a little over a year, almost a year and a half. I work as a production engineer there and I do a ton of data analytics and data science things relating to reducing our downtime, artificial lift optimization, and looking at different operators and how Chevron is performing compared to those operators. I have 10 years of industry experience, primarily in reservoir engineering, asset development roles, and production engineering, primarily in the field, in doing technical studies and production engineering. Worked for a number of companies in the Permian, lived in Midland for about 8 years and counting, and all my experience has been in the Permian. I have a bachelor's degree from the University of Texas in petroleum engineering, a master's degree in petroleum engineering from Texas A&M University, and then a MBA from the University of Chicago Booth School of Business. Thanks for having me.
Thanks, Yogesh. Branden?
My name's Branden Pronk. Thank you for having me. I've been in the industry for just over 15 years, started in 2008. I'm from Calgary originally, and then came down to the U.S. For college, graduated with a degree in mechanical engineering, a bachelor's degree. After that, when I started working for EOG Resources, both in Canada and then Bakken, worked for them for about 6 years. Early 2017, moved to Midland. I tried to get a master's in petroleum engineering online and got put on academic probation. So Yoshi's much smarter than I am. But since I've been kind of an entrepreneur in the oil and gas industry, so I was a production engineer at EOG, then a production engineer at SM Energy. My subject matter expertise are ESP, and then I was one of the pioneers behind high pressure gas lift at EOG and then at SM. Written a few SP papers, and now I run Dwiggins Consulting, which is probably the largest ESP-focused consulting firms, both domestically and internationally. So been on the production side my entire career, in unconventionals my entire career. So really focused on high rate, high liquids production, unconventional oil and gas wells, and our artificial lift related to producing. That's me.
Thanks, Brandon, and for both of you as well. So, with that, let's just dive into our discussion. So, to start, I would like to ask both of you to share your perspective on the biggest production challenges that we see in the Permian today. We'll start with you, Goshri.
That's a great question. There was so many challenges I can think of right now in my mind. From an operational standpoint, it is understanding the trade-off of understanding the trade-off of downtime versus making sure that you're getting the right cash margin for production. Also trying to figure out the trade-offs is how much preventative maintenance do you have that's appropriate to trade off the downtime as well as getting that production uplift to pay off everything. So day-to-day operational things is what I would say has been the biggest production challenge. It's like, yeah, how do you keep production going? And when production is down, how do you prioritize? What's the best priority of your production and how well are you going to get that back? That's the operational piece of it. And I think the production challenge is still going to be, are you making the barrels that you promised? That's the asset development challenge that I could think of for production.
Thanks, Goshri. What about you, Brandon?
So I've been involved in designing artificial lift and producing wells, in Canada, and in a few places in the U.S., the Bakken, the Permian. And some of the common themes I see are, these unconventional wells. When you complete them, you're pumping a lot of water, millions of barrels of water. You're pumping millions of pounds of sand. Your lateral lengths may vary, but 1 mile, 2 mile, now 3 mile laterals. And there's a lot of things you have to think about when you start producing a well. So, for example, when you first start producing an unconventional well, in places like the Delaware Basin, it may be overpressured and you may be flowing for a long time. In places like the Midland Basin, depending on the formation, it may be dead or it may flow, maybe under pressure, it may flow for a week or two, or be dead right off the bat, and you have to figure out what sort of artificial lift method you're going to use. Now, based on the bottom hole pressure, the water cuts, and the GORs or GLRs, you're going to have to decide now which artificial lift method is appropriate for this well. And to decide that, it's more than just technical. Some of it has to do with the priorities of the operator. So, for example, are my priorities keeping low LOE, lease operating expenses? Do I have a robust centralized gas network where I can use centralized, compression so I can gas lift a lot of wells at once? Or if I want to gas lift my wells, am I installing, a compressor per well or a compressor on each pad? What do my right of ways look like? There's a lot of operational things that affect your artificial lift decisions and your production decisions than just, hey, is an ESP or gas lift best for this well? Early on, kind of your flowback strategies. Am I opening this well as quickly as possible, blowing it as hard as I can, like we did when I was at EOG? Or do I have some sort of flowback schedule, some sort of slow back? Do I think that opening it up slowly and controlling my drawdown is going to be better for long-term EUR? So you also get into, each discipline has their own goals and incentives within the operator. So drilling has their budgets. They have their goals on their AFE. They're incentivized to drill quickly and have as few days from spud to TD as possible. And also, 5.5 20-pound casing is cheaper than 7-inch or 7 5/8 inch casing. Even though, from a production standpoint, the production engineering department would like larger casing for longer term. That opens up a lot more options from an artificial lift standpoint. The the drilling guys have their own incentives, and then the completions guys have their own incentives. So when you're drilling out a well, you don't want large casing because your AVs are lower and it's harder to get returns when you're drilling out plugs, and they like smaller casing for that, right? So you have to balance from the production side. You might want, it might be better for artificial lift to have 7 5/8, or 7-inch instead of 5.5 casing, but you don't get to decide that, and you have to, work with the other departments in order to convince them or deal with whatever they give you, right? So when you're looking at artificial lift, you need to understand, what does my well look like now? What will it look like in 12 months? And what will it look like in 5 years? And how do I design my artificial lift system to be the most dynamic for those time frames? So, do I go with gas lift now and conventional gas lift? I may take a cut on my IP rates, but I won't have to spend a bunch of money on an artificial lift conversion workover in a year or two. There's these wells are so dynamic, and then when you look at, companies may be drilling wells to hold production on a section, and you install artificial lift there, and then later on you come in and you infill develop there and you get frac hit. You have to understand, I might have gas lift in those wells now, and if I frac hit myself, well, gas lift is not good at unloading a frac hit and unloading all that water and sand, or all that water in order to get my hydrocarbons back, and I might need to put an ESP in it then. So understand what your development program looks like also affects your artificial lift decisions. So, these wells are so dynamic, conditions are always changing. One artificial lift method is not going to be the best artificial lift method across the board, and you might have different strategies based on what formation you're producing out of, what the infrastructure looks like on surface, what your infill drilling program looks like and your development program looks like in the future. The goals that the operator has in terms of LOE, OPEX, and CapEx. So there's so many things to be looking at. It's not as simple as, hey, ESPs are good and we're going to put an ESP in every well, or we like gas lift and we're going to put gas lift in every well.
Um, um, Thanks, Brandon, for this detailed answer as well. Been taking notes actually because you kind of answered some of the questions as I was preparing for you. So we're gonna actually go back to some specifics on them later. So,
Okay.
so Goshri, when we talk about, you mentioned something, or you pointed one of the challenges in a question saying, are we making the barrel of oil we promised? And so some of this has to do with really the unpredictability about how the decline in oil productivity would go over time. So, in your opinion, um, why we see sharp decline in well productivity decline over time? Is it mostly pressure depletion? Is it near well bore issues? Is it suboptimal frac treatments or something else or a combination? So I just, from everything that you looked at so far in your experience, what do you think is really the cause behind that?
Thanks for the question. When we define sharper decline, I think the way a lot of people in asset development evaluate that is looking at analogous wells, whether if it's geologically analogous wells in the same formation, same completion vintage, same vintage of when the wells have been producing with over the past couple of years or so. There are some metrics that are used to evaluate what an average decline looks like. Now, if the subject well has a sharper decline than predicted, a lot of it has to, a lot of that analysis, I hate saying it depends, but it really could be anything. There could be an operational issue with that, in the sense that if there is any sand bridging happening in the lateral, you may want to do not the most invasive thing like a lateral clean out or anything, but you may want to do something less intrusive to flatten that decline rate. If there is a sharper decline, another thing to take into consideration is if there's any fracture driven interaction effects or fragment or frac hit effects that have impacted the nature of that particular well's decline. Then the other thing to look at is to understand the artificial lift strategy. Was this particular well an ESP well compared to the other wells that were used in the baseline predicted performance, like all either smaller ESPs or gas lifted wells? So looking at the artificial lift strategy of that, you don't have that kind of granularity from public data. If you do have that from data traded data, that's something to look at. Then there's always operational considerations where you don't have the granularity of the completion data that you have from public data because you have proppant per foot or you have fluid per foot. There's also cluster spacing to take into consideration. So is that different? Are those metrics that aren't being reported, are those the differentiators of creating sharper declines? And then finally, you look at how you flow back those wells. Again, that goes back to the artificial lift strategy. Did you put the biggest pump possible? That's why you had the sharper decline. Now, I hear this all the time externally too. I hear a bunch of chatter externally as well, where you really need to ask the question, is the sharper decline the actual metric that we should be looking at? Or should we be looking at the actual area under the curve compared to what was the original type curve at average? And are you making money? Are you making more money than predicted? What I'm saying is you don't need to worry about the nature of the decline because there are other factors to take into consideration. If you're still accelerating production, and if you are paying, if you did it in a cheaper way than what was predicted or what was AFP'd, and if you did it in a way where your IPs were a lot higher, basically what I'm saying is if that area under the curve is a lot higher than what was in the predicted performance or what was in the promised performance, you shouldn't be worried.
Thanks, Yogesh. I'm taking notes on this one, and I know that session is recorded, but I advise everyone also to just keep taking notes as we go through this. So for the Q&A session, we can go through them. So, Branden, so your your expertise specific right now, what you have been really most focused on when you're talking about the challenge has been always artificial lift. And you said usually, you look at compressors, you look at the availability, and you go should also touch a bit on that. So assuming the sky's blue and you have gas, you have all the pumps available to you, and and what will be the best artificial lift system for the Permian, both in the Midland and in the Delaware, and how are companies optimized lift systems for low pressure wells in general?
So again, from what Yoshi said, the answer is it depends, right? So there are so many formations that we're producing out of in the Permian, and within, even the same formation a few miles away is going to act differently. So I have a few rules of thumb based on, bottom hole pressure, water cut, and GLR. So it's liquid ratio, water cut, bottom hole pressure, depth. So in general, the higher your water cut and the lower your bottom hole pressure and the lower your GLR, those are more ESP wells, right? And the lower your water cut, the higher your GLR and the higher the bottom hole pressure, those are going to be tend towards gas wells. Now we know GLR rises over time. And so, you have to think about, will this be a gas lift well in the future? Will this be rod pump well in the future? And more, because our pad drilling, our step outs, and our extended reach wells, in the Permian at least, fewer wells are kind of rod pump appropriate later in life because they're not good for very deep. They have bad dogleg severities. They're higher fluid rates or higher gas rates, and so rod pump doesn't do well. So what you see generally is the Delaware Basin, it's higher bottom hole pressure. It might be higher water cut, but it's much higher gas rate in general. So those wells are more conducive to gas lift or high pressure gas lift. So high pressure gas lift is where you get a compressor, a booster compressor that can go up to 4,000 or 5,000 psi. You inject down the tubing, produce up the annulus at a single point at the end of tubing without using gas lift valves. So the idea behind that is in conventional gas lift, you have these stations that go down the tubing, and when you only have 1,200 pounds to work with, you can only get so far down the well. You lift from some station way up hole, you're only lightening the gradient, part of the gradient of the well, not the full gradient of the well. A lot of times you might be injecting down the casing, producing up the tubing. The cross-sectional area of the tubing is much smaller than the cross-sectional area of the casing. So what you're doing is you're reducing the forces working against you, and then you're maximizing working the forces working for you. So that offers a lot of flexibility, because when you go down, you might be able to IP at 10,000 barrels a day. And when it kind of goes down to 1,000 barrels a day, you can switch and go down the casing, up the tubing as well. That way. So we see in the Delaware Basin is a big user of high pressure gas lift. The Midland Basin also has a lot of high pressure gas lift, but the Midland Basin wells, there's a lot, the Midland Basin wells are lower pressure, lower Sprayberry wells, higher water cut. Your Wolfcamp A's are higher gas, your Wolfcamp B's are even higher gas. The deeper you go, the more gas you get. So in the Midland Basin, the deeper you go, the more probably appropriate it is for gas lift, and the shallower you are, especially in the lower Sprayberry. And the Dean, some places in the middle Sprayberry, those are good ESP. So generally, my rule of thumb is if you're 80% water cut and higher and 500 GLR and below, probably need. If you're 80% water cut and lower, do you have 1,000 GLR and higher? That's probably going to be well. But that's like the back of the napkin that I use when I start, and then of course I'll do nodal analysis in order to refine that. See if that's actually.
Oh, thank you, Brandon. I appreciate the detailed answer. Yogesh, so on the topic of water and gas, so how do operators handle excess water and gas in aging wells?
In what kind of wells?
In the aging wells.
In aging wells, okay. How do operators deal with water and gas production in aging wells? Okay, well, it varies with each basin, and it also varies on the infrastructure too. So for example, there are opportunities to do saltwater disposal placement, and if you own your saltwater disposals, then you run studies or you run an analysis on what is the right SWD placement to inject all that water. And then the question, you hear a lot about induced seismicity, you hear about regulatory compliance on induced seismicity, and the question then becomes, well, where do we end up injecting all this water that we produce in the Permian? Then it goes back to, well, how much money do you want to spend to get rid of the problem? What we consider is the problem, because water doesn't make us money. So there are studies you can run in terms of dealing with the right SWD placement to reduce the kind of communication of water encroachment in your next producing wells or in your unexploited acreage. And or you could have contracts with our third party, those SWDs. Then you can have those contracts to as wherever they're placed, so you don't have to, so you can reduce that disposal cost depending on the contract. So that's how you deal with the water for aging wells. I mean, for gas, that's also a great question, because then you think about emissions management. If you don't have the infrastructure to process that gas or to send that gas to sales, and if there's any operational issues to where you'd have to flare or vent. So to deal with gas and aging wells, you would have to make sure that the contracts with your midstream companies are competitive or accretive for your business. And based on your gas projections, making sure that those contracts are pretty fungible to ensure that you can still send the gas to sales. If you have to flare, or if you have that zero emissions promise or commitment, then yeah, that is going to impact production outcomes, or that's going to defer production. So dealing with water and gas and aging wells really does depend on, it's more than just the technical stuff. It is a lot to do with making sure that you have the right kind of projections, and you are refining those projections when making contracts with your midstream companies, and then making sure that you have the right projections for your water disposal, whether if you want to go third party or whether if you want to own that saltwater disposal, and then also run studies to make sure you have the optimal SWD placement. And then for actual, and then if you have your own gas processing, you make sure you have the infrastructure to know that based on the kind of gas that you do produce, or the elements of the gas that you do produce, you have the right kind of facility to scrub that gas to meet some of the midstream, like when you go to sales, to meet some of midstream's commitments, or to meet midstream specs on sending that to commercial, sending that to sales. So there's a lot more than the technical stuff that gets involved in dealing with water and dealing with gas. I will say that gas does make you some money, right? It also depends on how rich the gas is too. So you don't always have to knock on gas. The other option I also thought about is, depending on how much gas you do have, there's some research that I would suggest you guys have, and I think Branden might think about this a little bit too. He probably was at EOG when this was being started, and it's closed loop gas capture. So New Mexico, for example, has a pretty is well aware of the closed loop gas capture projects that some operators have initiated. And I know EOG definitely touts the closed loop gas capture projects that they have had in New Mexico of the Permian Basin. So you may want to do some research on closed loop gas capture to make use of the large production of gas that you do have, and keep it within your network. Now, there's also some other efforts that have been done to deal with gas, and that is enhancing recovery. So there is that hydrocarbon gas injection there's studies that have been conducted as far as simulations go. But then the question comes is, how economic is that going to be? How much uplift can you promise? Can you deliver the barrels that you promise? So there are a lot of options, and I believe that as wells age, you have to get a lot more creative, and the deviations in production causes you to be creative. So these are some of the things that I've seen as far as the water and gas and aging wells.
Hammer, you're on mute.
I'm on mute.
Hey guys, sorry, I had to restart quickly. I had something quickly going on. I just missed the last 30 seconds. Yogesh, when you start talking about UG, gas capturing part. But I captured most of it. So, Branden, going back to you on, so how are facility design strategies basically are changing for small and large operators over time?
So as a production engineer, I'm very greedy, and I really like having daily well tests or multi-phase flow meters that give me live, oil, water, gas production. But more and more, as oil companies scale, you see a lot of bulk and test facilities or centralized facilities. I've seen strategies, where you might have a bulk and test facility, and then you might have multi-phase flow meters on your wells. Multi-phase flow meters are used for allocation from your bulk and test to know how much, because the multi-phase flow meters aren't always exactly right. They need some calibration. But when I first started my career, it was predominantly 1 3-phase test separator per well. So you always get daily well tests. Like I said, more and more, you're seeing bulk and test where you have multiple wells going in one facility, and you might have 1 or 2 on tests at a time, and then you use those well tests to allocate through, as you swing other wells into tests the next days, and use those old west well tests to allocate, how much production is coming each well. So it's a scale thing. People are trying to save money on their facilities, because facilities are getting more and more expensive. Steel is getting more and more expensive, especially with tariffs and different things. And everything in the oil field, especially facilities, is all built out of steel. So when I first started, you might AFE, per well for a facility might be $300,000, per well for a facility for, individual test separators. Nowadays it might be $750,000, right? So the cost has increased significantly over the years. So operators are looking to save costs. Now, something else you need to think about is, with the nature of these wells, when you bring them online and they're producing thousands and thousands and thousands of barrels a day, maybe 10,000 barrels a day, and later on in life, they may only be producing 500 barrels a day or less. How do you build your facilities so that they're flexible, and the test separators you need early on in life are not necessarily going to be the test separators you need later in life? So bulk and test also gives you that flexibility, but selfishly, I prefer when every single well has its own test separator, and I get well tests every day. But that's not always the case. I really like data, right? So I want all the data that I can have to do the nodal analysis and all the sensitivity analysis. I want to be able to understand how the well is really performing, and I don't want to feel like I have to guess based on an allocation that might be wrong. 'Cause production allocation is there's reasons why there's whole teams dedicated production allocation, right? It's not always very, very cut and dry. Sorry, Amir, you're on mute.
Say this again. As you are absolutely right. I think the common theme as of now is like, there's no one solution fits all. There's a lot of engineering, a lot of modeling needs to happen for as we go. So it's not yet a factory design as it seems in most of the cases. People, I think, are trying to move into this, but it seems to be an ongoing optimization as we learn more and we gather more data across the board.
And the biggest constraint I think I've seen is on the water side. So if you bring on a pad of, a couple pads of 5, 10, 20 wells all going into the same facility, early on you're producing mostly water. And so I have seen a lot of cases where your water takeaway, whether it's your SWDs that are connected to those or whatever, are constraining how hard you can pull on those wells, or how high you can produce those wells. So your SWD might only be able to take so many thousands of barrels a day, and these wells you bring online are producing more than that. So you have to choke those back so that you don't outrun your ability to dispose of your water. So I've seen that as a constraint a lot early time in wells, where your high water production is constraining how quickly or the production you can get out of the wells.
All right, so I want to start talking about something slightly different, and that question goes to you, Goshri. So when it comes to the EOR and well stimulation initiatives on producing assets right now, which strategy you think would be most effective? I'm talking between small and big volumes using diverters, not what sort of chemicals, what sort of things that you think is more adequate to deal with this. Since that thing is still it's a hot topic and a lot of operators are experimenting a lot with it.
So is the question, what kind of chemical program or what kind of chemicals would you suggest?
It's I'm talking specifically about the strategy, like for small versus big treatments, using diverters or not, when we treat these things, given the long laterals and the different type of chemicals. We have so many options, we have so many problems. So how what are the current strategies to tackle this, and when it comes to EOR and well stimulation initiatives?
Okay. Well, with EOR, the assumption is that you are enhancing the recovery after the well has been online. That's how I'm going to define it. And then the well stimulation is going to be you're enhancing the production right before the well. In order to get the well online. So there are different chemical programs for that, of course. For EOR, well, or even just any kind of production enhancement, lots of studies do require that you need to have some sort of compatibility testing or some sort of fluid testing to make sure what kind of minerals are you getting from the ground? Like what kind of scale are you getting if you're getting potential for scale? What kind of what does that makeup look like? And if they're bugs downhole, what kind of biocide do you need? Then it's not even just diagnosing what kind of chemical that you need. The OpEx that you need to take into consideration is like, how much is too much? How much is enough? Are we underspending or are we overspending? Are we over-treating? Are we under-treating? What is the sweet spot? So when it comes to like any type of production enhancement after when you turn on the well, you definitely need to do some fluid testing to understand what kind of chemicals you do need. And then in my dream world, other than trial and error of overstimulating or understimulating, of over-treating or under-treating, coming up with a predictive way to know that, hey, you're injecting too much or you're injecting very little. And that way you can have those cost savings in your chemical OpEx, or you may end up understanding that your chemical OpEx is going to have to be a little bit more than what you were doing, but the uplift is there, or the production is stable. So I would like to have in the perfect world, I would like to have some data behind how much is too much chemical or how much is too little chemical in order to get the right kind of return or the economic production that we promised. Not just the numbers of not just the number of barrels, but also how much money you're making for that particular well or that project. Now for well stimulation, yeah, there's been lots of talk on surfactants in the industry, and there's a mindset that the way you the right way to use a chemical is if you use that chemical right the first time, like when you're treating the well. So lots of studies on surfactant. The jury's still out as far as how it works for different operators. What I do suggest that when it comes to chemicals for well stimulation, one thing you have to keep in mind is like what is an output from lab studies is always going to be different because there's so many factors to take into consideration when you're actually applying it to the field. So having control wells that have everything in common except the lack of chemical for the stimulation versus the subject well where you have the chemical for the stimulation, and knowing that it's going to make a noticeable uplift, or that there isn't any natural variance when you see that when you have that uplift. That is, in a perfect world, that's how you can say that chemical is effective. So yeah, even though the lab studies will say that theoretically this is supposed to work, and I don't discount those lab studies at all. You have to do your due diligence on understanding your reservoir. You have to do your due diligence in understanding whether if you're over-treating, and you have to do your due diligence on how you measure success. So I think the chemicals you're going to be successful as long as you have a defined objective on what makes it successful. If it is like a 2% uplift, then you have to ask yourself that question: can you even measure 2%? If it's a cost savings, Is it easier to measure cost savings than a production uplift? I think so. But those are some questions you have to evaluate when it comes to like what are the optimal chemicals for EUR and for well stimulation.
Absolutely, you're absolutely right, and I know we can literally have a full conference just talking about this particular area, not just one session, because I feel like with the focus of the industry in hydraulic fracturing for so long, and most of the money was going into just drill frac and just keep going, and now are trying to understand the stimulation of these things and different chemicals, and when we need at the chemicals, that's another thing. The other issue that I'm seeing also across the board is how we and you touch base on this is the connection between lab testing and field data. For example, when you look at surfactant, you have most people do IFT, contact angle, some basic testing, but I did not find personally any correlation between these lab results or not. It doesn't mean that thing is working here. So looks like we need to even reinvent our lab testing for the lack of better words. Um, so Branden, we still on this topic, and I know you we talked about one of the issues that we always see is scale, and the scale it changes not just within the basin, it changes from one spot in the well to another spot on the same well. um, this is what we have been seeing, and probably have experienced something. So what type of scale do you typically see, and how do operators manage scale build up over time? Talking different strategies between scale inhibition versus scale dissolving, and how can we deal with this complex problem, actually, because the sort of skills that change, as you know.
Yeah, so one common issue I've seen throughout, whether it's in the Bakken or the Permian Basin, is iron sulfide scale. So if you have any sort of trace of H2S in your well, there's a huge chance that you're going to be seeing iron sulfide. And with that iron sulfide, because there's sand, frac sand down there or something, what you see is this iron sulfide sand matrix that is very, very hard. So that presents two, issues in two big places. Number one is iron sulfide precipitates out of solution with heat, so higher heat, more propensity for iron sulfide to precipitate out, and then also pressure drops. So in areas where there's large pressure drops, iron sulfide is also prone to dissipate or precipitate out. So when you look at artificial lift strategies and you look at ESP, well, when you have a 5.5-inch 20-pound casing with a drift diameter of 4.65, whatever, and then you have an ESP in there with an ESP motor that's 4.56, there's a tenth of an inch clearance around there. And then your ESP pumps are 4-inch, so you have about a half an inch clearance. What happens you're producing high fluid rates, so your linear velocities in those very, very small cross-sectional areas are going to be very high, and the cooling mechanism that the ESP uses is convection of the fluid running up past the equipment, right? So you're seeing the high heat, high pressure drop. And so what you see, especially in ESP operations, is you see a lot of iron sulfide or other scales, if there's no H2S, precipitating around those areas, high pressure drop, which would be around your motor, between your motor and your casing. So you can very quickly with, say it's concentric, it's not going to be concentric, but say it's concentric and you have a fifth of an inch clearance around the motor, between the motor and the casing, you can sometimes scale up very quickly around the motor and between the motor and the casing. And then you essentially don't have any more flow from below your ESP to above ESP into the engine. So you block it off, and no more, you can't produce anymore. Another big issue is around the perfs and in the laterals. So you'll see declining inflow performance because you're scaling up in your perfs and your laterals. You may have sand bridges, sand and scale mixtures that might be blocking a large portion of your lateral. You might have scalings across your perfs. And so when you look at most of the well stimulation operations that have been a part of are clean outs. So from if you back up, if the scale are just your ESP or within your ESP and the outside of your ESP, a lot of times you'll do flushes down the tubing. And you'll lead that either with an acetic surfactant or acetic soap, or you'll lead it with 15% dual inhibited HCl, and then you'll tail that with produced water or fresh water and flush that through the pumps, or try to spot it at a certain part of your equipment so that you get the contact time to dissolve that scale. And then you might tail that again and flush that away and then restart your ESP. But then when you're looking at how do I treat my lateral, I've been a part of, efforts to do high rate flushes. So whether you have an ESP in the hole or you pulled it out of the hole, you're trying to get really, really high rate and pump acid and try to get that into your perfs. But a lot of times your first perfs in your heel will just take that fluid. So I've been involved in trying to use diverters and, staging, diverter sweeps in order to try to get more and more down the lateral. But if you pump acid with that, that usually breaks down the diverter. So then you get into clean out operations. And what's really hard about unconventional wells, especially low pressure, is that it's hard at very low pressures to get returns. So you might be pumping 12 barrels in to get 2.5 barrels out. And you need the linear, the fluid velocities in order to bring the returns to the surface. And so I've used, diverters in some wells successfully, some wells unsuccessfully, in clean out operations. And then a tricone bit might do it. You might not do it, so you need a full drilling bit to be able to break through that scale and that sand matrix and clean out the well. Then eventually, when you get to the bottom, you can come out pumping acid to dissolve all that. But on the operational side, you'll see, hey, do I want to clean out with stick pipe? And if that's a daylight rig, I can't leave that down hole. I have to come up above the kickoff point every night before we go home. Or do I do a 24-hour rig, stick pipe, or do I do coil? Coil can probably do it much faster, but if I get stuck using coil and I have to fish using coil, that's going to cost a lot of money. So it's not just, I'm not, a chemist, or don't have a master's degree in petroleum engineering. I'm very operationally driven. So a lot of the decision making when I'm looking at well stimulations like clean outs are very operationally focused, and that's kind of how I think through things. Hey, Amir, you're on mute again. Sorry.
It looks like there's some background noise on my end, so I keep getting automatically muted. Thanks, Branden. So on still on this topic, and from the things that we have seen as of now, are there any new chemical or mechanical innovations that work well, or that's still more trial and error, and we still have a lot more to learn before we have an optimal solution for these sort of issues? Yogesh?
Okay. So are you saying that are we still working on it in terms of finding the right chemical or finding the right operation philosophy?
Yeah, so Branden was talking about, for example, when you have the issues downhole and the scale and all of that, there's a lot of operational questions that need to be asked. What sort of things we use? So I mean, most of this was mechanical. So from what we have seen so far, is there a rule of thumb between chemical and the mechanical solutions that work really well, that we have seen working very well, or that's still work in progress in general?
That's a good question. I do think it depends on the operation philosophy of the particular company. So I hate saying it depends all the time, but the way that you might want to approach it is, again, what is going to make you money, or what economic metric are you going to use to say that you are performing in your asset. So if it is that mechanically you've done the study, the reliability of that particular the ESP is doing really great compared to some competitor data for ESPs, then you might want to look at your chemical program. Why isn't my chemical program not making me competitive? Now, if your chemical program, you're doing everything as prescribed from the chemical provider, and you have poor reliability on your ESPs, whether that's intended or when I say intended is, oh, you just run the biggest pump until it breaks down. And you did that on purpose because that makes more money. But if you know that wasn't the intention, then you may want to, then you may want to look at your ESP reliability. And it definitely, every operator is going to have a combination of whether if it's your chemical program and the level of reliability or the level of how hard you're going to run that ESP or run your artificial lift to make money. Is that combination cheaper than doing everything right? When I say right, doing everything as prescribed, or doing everything as in you're making you're babying your ESP to make sure it doesn't break, but that's going to sacrifice production, probably. I don't know. Then you are using all the chemical in the world to make sure that you are not going to produce a single thing of scale. Is that can you cut back a bit to still get the same kind of production? Where's the diminishing returns? I would say there is a sweet spot associated with that. It does depend on the operator's philosophy and the operator's expertise in terms of, hey, maybe in this particular reservoir, we're always going to have scale no matter what. We've seen it. We've seen it in our variety of ESPs and thousands of our ESPs, and scale is going to be an issue. So yes, we're going to have a chemical program. However, we are really good at maintaining the reliability of our ESPs. And that is correlated to the economics, or that is correlated to the economic metrics that we hang our hat on, that we're saying that we're doing good. So metrics of success is really important. We're defining that clearly is very important. I would like to see a chart, or I would like to see some sort of operating philosophy kind of study, or operating philosophy kind of public data in the terms of where bubble size is the economic metric of the particular operator. And then you have an X and Y axis of how much of chemical that they use, and what's their reliability on their ESP. So that would be a really cool if service providers actually have that, if they team up with ESP companies, or if ESP companies and chemical providers team up on that and with their clients, and if they are able to provide that the proxy for the economics being production at a certain time period, I think that would be pretty eye-opening.
Absolutely. Branden, I would like to also get an answer for you on the same question. So Yogesh talked about some sort of partnerships or data that we have to see between ESP providers or service company providers and the operators. So what do you think on this?
You're asking what do I think about the partnerships between the operator and the service providers?
Yes.
So I've worked on the operator side for a long time, over 10 years, and then since then I've kind of gone and started a couple companies and run a couple companies on the service provider side. So I've seen both sides of it. You just have to understand what the incentives are of the operator versus what the incentives are of the service companies. Of course, everybody's there to make money, and service companies are also there to make money. So it's really aligning kind of the goals and incentives so that you kind of you try to avoid, how do I say this? Chemical companies are there to make money. They want to sell you as much chemical as possible, right? ESP companies are there to make money. They want to sell you as many ESPs as possible. It's same with every single vendor out there. I mean, it's not malicious. They're there to run a business. They're there to feed their families. They're there to be successful. And we're capitalists, and I'm a capitalist, and I want to make money too. But in Dwiggins Consulting's business, we primarily operate as a third-party agnostic as Switzerland between the ESP vendor and the operator. So the ESP vendor, wants to sell as many pumps to the operator as possible, and they're not necessarily disappointed when a pump fails prematurely, because that means they get to sell them another piece of equipment.
Of course.
And the operator wants the longest run life available, right? Because they don't want downtime. Downtime's deferred production. That's money. That's spending more on LOE or on, artificial lift conversions, whatever it is. And so Dwiggins Consulting comes in as kind of a third party agnostic arbitrator that both the vendor and the operator can trust that we're going to be data driven, and we don't have any skin in the game either way. So as an operator, I don't think the operator should be combative with the service companies. There needs to be aligned goals. There needs to be partnerships in order to be successful, meet those goals. But you also have to understand, some things you might need to take with a grain of salt that the service provider is telling you. And you might need to find services like consultants or other services that kind of help you navigate that, right? So it's always trying to align incentives. I think partnerships can be very, very valuable between operators and service companies. And I've always tried to work collaboratively. Even if you might talk to some ESP suppliers that when I was an operator, they might disagree with that, but I always tried to be fair. But yeah, it's kind of a little bit of a dance and trying to align incentives and align goals. And I'm very operationally driven, so I feel like incentives with operational metrics attached to run life goals or things like that are always good. So I don't know if that answered your question, but that's kind of how I think about
Oh,
things.
it did actually. This is Brandon. So we have a few minutes left, and I have a couple of questions that I still want to ask. So you gosh, when you look at the ESG metrics, the economic challenges, how all of this is influencing production plans nowadays, given the current regulations, ESG metrics, water production, all of these things. So how all of this is really influencing production plans and production plan strategies in general for big assets.
I want to make sure I heard it correctly. ESG, right?
Yes, ESG and the economic challenges, both of them, kind of really how you do the balance between them in general.
ESG and the economics. Okay, great question. The thing that I will say, and one of the things that the industry really wants to make it clear, that even though that we are in the business of making money, safety is a priority, operational excellence is a priority, and one of the things that we talk about as far as Chevron's commitments to shareholders or Chevron's commitments to public is whenever we do produce energy, we're making sure that that energy is being produced safely. So ESG metrics in production is going to go hand in hand. And what I mean by that is when you have regulation and when you have maintaining your people, you're going to maintain that rapport. And when you maintain that rapport, you improve the focus, or you reduce the distraction on how you can achieve your production metrics or achieve the economic metrics. The other thing that I would like to say is there are so many ESG metrics, or there's so many ESG evaluation methodologies that in one of my classes on it was called portfolio management at Booth. we looked at different kinds of ESG evaluation methodologies for each company and just the correlations of all of them, or the different kinds of scores each ESG evaluation company or ESG evaluation entity had for particular companies. And it's all over the place. So what I mean by, I'm not discounting on ESG at all. But what I am saying is you have to be able to understand what the source of truth is what ESG metric that you're looking at, what is that methodology of scoring, and making sure that's aligned with the operating philosophy. And if that operating philosophy still adheres to safety and operational excellence. So that's something I just want to share. So, it really does depend on what ESG metric that what ESG entity, evaluation entity you're looking at. Okay. So as far as productivity goes, well, I think we need to avoid having the mindset that ESG is going to limit production. And I think the first thing that people think about is, well, I can't flare. If I can't flare, then I'm shutting in my well and I can't produce. As an industry, we've gotten a lot more creative in maintaining production, maintaining cash flow, and improving our reduction of methane emissions, our reduction in GHG emissions. I think we've come up in the learning curve in terms of that, whether if it's like technologies that we've invested in monitoring the types of emissions on our facilities, whether if it is understanding where the root cause of the majority of the emissions are coming, which is like your tank venting. So there have been a lot more monitoring and more granularity of that kind of data to educate us on where can we solve those problems. And we have gotten better in terms of still producing our wells, because if you look at some of the Permian emissions, I actually did this with my data science class at UTPB. When we looked at emissions over time, yeah, Permian started with a lot, but it actually reduced over time. So, but if you look at Permian production is still going up. So we've actually come a long way when it comes to ESG metrics. And I know I've talked a lot about the environmental piece, but I think that's what speaks to a lot of people in terms of safety. Like, how do you produce those barrels safely? And then from the governance and from the social aspect, there's tons of partnerships when it comes to the community to ensure that you are drinking clean water, we're not going to disrupt on your property. I think the oil and gas industry does a lot more than what people from outside the industry really realize, because that's our license to operate. So I will get off my soapbox, but we have to avoid the mindset that ESG is not inverse to productivity.
You're absolutely correct. And so we are almost, running out of time here on this thing, but very important thing I would like to get from you guys before we go to the Q&A session. I would like to ask both of you. We have actually a lot of our audience today are young engineers, some of them still students, and I would like to get an advice from both of you guys on how to help them succeed in their careers in general.
Want me to go, Hammer?
Go ahead, please, Branden.
Yeah, you can go.
Well, yeah, one minute for you, and then 1 minute for Yogesh, and then we'll go to the Q&A.
Okay, so as a student, what I recommend is, and I didn't go to a target school. I grew up in Calgary, and I went to a non-target school in the U.S. as a mechanical engineer. So it took a while for me to get my foot in the door, and I couldn't just apply to internships. So what I recommend is, if you want to work in the oil and gas industry, the oil and gas industry values experience over degrees. So getting a degree is kind of what you need, but more value, something that's extremely valuable, I think a lot of students don't understand, is instead of trying to graduate as quickly as possible or graduate with the highest GPA possible, what you need to do is you need to take every opportunity you can to get experience. So what that might mean is if you are out of high school and you want a career in the oil and gas industry and you go to study petroleum engineering, mechanical engineering, what you may do is find any job before even your first year of college that you can in Midland or in the Bakken or anywhere, maybe as a rustabout or literally whatever you can get, right? And then you may not be eligible for an internship after your first semester. Again, that summer you go get literally whatever job you can get. And you don't know who you might meet or what experiences you might get or who you worked beside or what may happen that will help put you on that path to getting that first internship and then that next internship. And you can't put yourself in those positions without being out and working in the industry. And I can't emphasize this enough, doing whatever job in the industry you can get, right? It might be working on a workover rig, pulling rods and pumps or ESPs. It might be working in a shop, redressing Packers. It might be on a rustabout crew out in Jal, New Mexico. Like literally whatever you can get will help you make the contacts you need, help you get the experience you need, so that when you apply for that internship, they see, oh, he's worked in the oil industry. He's had these really, really hard jobs that are not easy jobs. I mean, I think that's the type of person I would like to hire as an internship. And then once you get that internship, you can get the next one, and then you can get the offer with an operator or with the service company or wherever you want to work. But just experience is key, and any experience is what you need.
Thank you, Branden. Great advice. What about you, Godfrey?
Okay. I actually been thinking a lot about this because you're going to get different kinds of advice and you're going to have to follow your own trajectory depending on how many years of experience that you have and how many hours are you willing to put in the work and what stage of life you're in. Okay. When I graduated from university, I was super ambitious and I thought I'm going to be the CEO of Chevron or Exxon. I really thought that. I was always told that, hey, to move up in the industry, be the first one at the office and the last. Cool. Make sure that you are always delivering. Cool. Make sure you always perform. Cool. So then, depending on your company culture, you're also going to get feedback that, school taught you school gave you a background and theoretical knowledge. But what school hasn't taught you is how do you deal with people to get the job done. So over time, I learned that it wasn't about what I knew, it was about who I knew. So I really focused a lot on networking. I focused a lot on building relationships, maintaining those relationships, and sounds very sentimental, but when you ask people how they got their jobs, it wasn't because they looked at your GPA. GPA was probably a ticket to the interview, but they probably looked at your resume and they called up somebody that they knew at the company and they thought, what do you think of Yoshi? And based on that referral, people are going to start making that decision. Okay, she's on the short list or she's not on the short list. So you're going to be told a lot not to burn bridges. You're going to be told a lot that it is not what you know, it's who you know. But I will say that it's going to be a balancing game on everything, as in, don't rely so much on relationships that you don't have any substance or technical substance. Or don't think that you want to focus so much on the technical work and you think the work is going to speak for itself when in reality you never self-promoted. So there's a balance between that too. The other thing I would like to mention is you're going to reach a point in your life when you're like, how much time do I want to spend with the people that are my coworkers versus how much time do I want to spend for people who will actually be there for me in a life event? So if there's any overlap, cool. If there isn't any overlap, you may want to reconsider how you want to invest your time with people. What I mean by that is when you think of some company cultures or when you enter in an industry or enter in a company, some companies will work you to death. Some companies will give you a good work-life balance. So it is really up to you on what life that you want and what stage in your life are you willing to take certain kinds of workload or certain kinds of responsibilities. Like where do you want to write? Where do you want to have your name on?
Thank you, Godfrey. So we have about 5 minutes left, so we'll try to pick just some questions. You have actually a lot of good questions, definitely, and unfortunately, we'll not be able to go through all of them. So, Brandon, I have a question for you. The question is, with the very high number of artificially lifted wells in the area, what are the recommendations in monitoring to be able to maintain them running, especially with unconventionals?
Well, I'm a little bit biased because I started a software company and I offer services through Dwiggins Consulting for those things. But in general, you want as high frequency data as you can get, and that might mean an edge device, right? And then a platform that allows you to monitor. Most vendors have their own platform, and one of the biggest struggles is when you're using multiple vendors, you have to log into all their different platforms to see their own stuff, and each platform is different and functions different, and some are good, some are bad, and you need to remember your login for them all. And so whatever it is, a platform that can consolidate all those artificial lift systems or all those pumps from different vendors onto one platform, and then some sort of control room or remote monitoring system where people are watching those things and can intervene live and also quickly message and communicate with the guys in the field to both be able to have eyes on lots of things at once and then communicate with the guys in the field that can help intervene or help troubleshoot if the remote intervening isn't enough. So I'm not going to sell anything here, but I think those are the big picture things I would look for. And a lot of companies build those things internally, bigger companies. And then I'm sure Chevron has their own monitoring platforms and groups, and Oxy and others. And then other companies look at vendors to provide those things.
Thanks, Brandon. So a quick question for you also, Goshri. So how do you see the trend of water to oil ratio in the Delaware Basin, 4-1 to 8-1 compared to the Midland Basin, 2-1 to 3-1? Has it stabilized, or will it continue to rise, putting more cost pressure in years to come on Delaware operators?
That's a loaded question. Very loaded question. I can't give a exact number because every well is going to perform differently. Every asset throughout the Eddy and Lee counties are going to perform differently. The formation, depending on the wettability of that particular formation, that is going to impact the water saturation of those particular formations in the Delaware Basin and the Midland Basin. That's going to impact things. I'm not making excuses. What I will say is you're going to make a lot more water in the Delaware Basin compared to the Midland Basin traditionally. You're going to have more infrastructure stress in the Delaware Basin, not only because you're producing so much water, because you don't have that much infrastructure to begin with compared to Midland Basin. That's how it is. So with that being said, predicted water oil ratios will depend on the formation, your water saturation, the type of wettability is for that particular formation, whether if it's a child or a parent well. And it will also depend on whether if you have encroaching water production from your saltwater disposal.
Thank you, Goshri, and thank you, Brandon. We actually have about a few seconds left here, so unfortunately, we'll not be able to take more questions. Really, really want to thank both of you today, Yogesh and Brandon, for the all insights that you've given to us. I've been taking a lot of notes. I learned a lot today. I hope everybody who listened to this panel learned something as well. If you guys have any questions or something else, let us know. I know Ahmed is recording this presentation. He would send the recorded session to everyone. So please listen again. I will make sure I will do that and basically take my time to get more notes on it. Thank you everyone for listening. And thanks again, Yogesh and Brandon, for taking care of us today and giving us all of these insights.
Yeah, thank you for inviting us. And just anybody that wants to reach out to me, feel free to reach out to me on LinkedIn. And I try to be an open book and I try to engage as many people as I can. Sometimes I get busy, but I promise I'll get back to you.
Right.
Thank you for having me.
Same here. Thanks so much, Yogesh. Thank you, guys. Bye.